So in our previous problem, we were finding the vertex and axis of symmetry in vertex form. Here in this example, we're going to find the vertex and axis of symmetry in standard form. So your standard form is where you don't have any parentheses. You just have an x squared term, then your x term, then your constant. So your variables are in descending order according to their exponents. So to find the vertex and axis of symmetry, we have 5 steps that we can follow. So the first is we want to put the quadratic function in standard form. So I want to have nothing, or at least the y, on one side, and then I'm going to have the x squared term, followed by the x term, followed by the constant term. And then step 2, I'm going to identify the numeric values for the a, the b, and the c. If one of those values is absent, we'll put a 0. So then to find the x-coordinate of the vertex, I'm going to use the formula x equals negative b divided by 2a, and I'm going to plug in the values of a and b from our standard form to find that. Once I have my x-coordinate, I can go on to the next step, and that'll allow me to find the y-coordinate for the vertex. And all I'm going to do is take that x I found and plug it into the given equation for the quadratic function. So between step 3 and 4, I will find the vertex of the quadratic function, so I'll find the vertex of the parabola. And then in step 5, we can find our axis of symmetry, and that actually comes from what we did in step 3. That is the same as the x equals negative b divided by 2a. So it's, remember, the x-coordinate of our vertex. So let's look at a couple of examples of finding the vertex and axis of symmetry. So here in 1, I have g of x equals negative 3x squared plus 12x subtract 10. So I want to make sure it is in standard form, and it is. So the first thing I want to do now is to identify the a, the b, and the c. So my a is always with the x squared, so in this case my a will be negative 3. The b is always with the x, and that will be 12. And the c is always the constant term with no variable, and that would be negative 10. Now I can proceed to find the x-coordinate of my vertex, so that's using the formula of negative b divided by 2a. We said our b term was 12, so the opposite of 12 would be negative 12. And I'm going to divide that by 2 times our a value of negative 3. The negative 12 will just carry over, and when I multiply 2 times negative 3 in the denominator, I'm going to get a negative 6. Now I can simplify negative 12 divided by negative 6 to give me a positive 2, so I know x to be positive 2. So as far as my vertex goes, I know that the x-coordinate is going to be 2. Now I can find the y-coordinate by simply plugging in that x value into the given equation. So I'm going to have y equals negative 3 times 2 squared plus 12 times 2 minus 10. I can put all of that into my calculator, and it'll give me my y-coordinate. It's going to give me a y-coordinate of 2. So my vertex will be at positive 2, positive 2. Now for my axis of symmetry, it does go through the x-coordinate of the vertex, so that is going to be x equals 2. So we're going to do the same thing in number 2. I want to look at the equation x squared plus 16x plus 64, and I want to make sure it's in standard form. So my x squared, my x, and my constant term are all on the same side. Since it is in standard form, I'm going to identify my a term, my b term, and my c term. So my a term will be 1, my b term will be 16, and my c term will be 64. So now I can find the x-coordinate of the vertex by using the same formula we did in the previous, so negative b over 2a. My b term is a positive 16, so I'm going to make that a negative 16 in the numerator. If my b value would have been negative to start with, I would switch it and make it a positive. In the denominator, I'm going to take 2 times the a, which we have is 1. 2 times 1 is going to give me a 2, so I have negative 16 divided by 2, which simplifies to give me a negative 8. So the x-coordinate to start off my vertex is -8. To find the y-coordinate, I'm going to plug in. So I'm going to take -8 squared plus 16 times -8 plus 64. I'm going to plug that into the calculator to find my y-coordinate. It gives me a y-coordinate of 0. So my vertex is at -8, 0. And then to find our axis of symmetry, it just goes through the x-coordinate of the vertex. So my axis of symmetry will be at x equals -8.